In this example, we want to find the sum of the terms of what we are told a geometric sequence. Since we know the formula for the first n terms of a geometric sequence, we'll have to apply this formula, and to do so you have to find the values of a sub 1, value of r, and value of n. So let's look at our sum. First, let's write it as a true addition, so we can determine the terms of the sequence. So we have 4 plus -6 plus 9 plus -27 over 2 plus 81 over 4, and so on until we'll arrive at the term 3 to the power 16 over 2 to the power 14. Therefore, we can see that the terms of the sequence are 4, -6, 9, -27 over 2, and so on until we'll arrive at the term 3 to the power 16 over 2 to the power 14. So the first term of this sequence is 4, and therefore we can say that a sub 1 is equal 4. To find value of r, we'll use the definition, namely that r is the ratio of any two consecutive terms. We can choose terms 1 and 2, and that ratio is -6 over 4, which is -3/2. So -3/2 is different than 1, and therefore we'll use the first formula for the sum of the n terms of geometric sequence. But to do so, we need to find the value of n. And we look at the last term in that sum, which will be the term 3 to 16 over a to 14, and this is our term a sub n. On the other hand, we know that for a geometric sequence, a sub n is a sub 1 times r to the power n minus 1, and this will allow us to find the value of n. So a sub 1 times is 4, the r is -3/2, so we have -3/2 to the power n minus 1. And on the other side, we'll have 3 to the power 16, this is the value that was given, over 2 to the power 14. Let's divide both sides by 4 to get power on the right hand side, so we have -3 over 2 to the power n minus 1 on the right, and on the left we'll have 3 to the power 16 over 2 to the power 14, and since we divided by 4, 4 is going to go in the denominator. 4 is also 2 to the power 2, and if we multiply those exponents, 2 to 14 times 2 to the second, we'll have 2 to the power 16. And therefore, left-hand side can be written as 3 to the power 16 over 2 to the power 16. And because the exponents are the same, we can write it further as 3 over 2 to the power 16. So on the left-hand side, we had 3/2 to the power 16, and on the right-hand side, we had -3 over 2 to the power n minus 1. And because the exponent on the left is even, we can, instead of 3 over 2, write -3 over 2. And therefore we'll have that -3 over 2 to the power 16 is -3 over 2 to the power n minus 1. And this is going to happen when 16 is going to be n minus 1, and therefore n is going to be 17. We've given n and the values of a sub 1 and r, we are ready to apply the formula. The formula tells me that we need to take the term a sub 1, which in our case is 4, and multiplied by a fraction. In the numerator we'll have 1 minus r, which is negative 3/2, to the power n, which is 17, over 1 minus r, which will be 1 minus negative 3/2. Now we can simplify this a little bit more. The 4 goes to the numerator and we'll have 1. Negative 3/2 to the power 17 is going to be negative number because we have negative 1 times 3/2. So together with negative in front, it's going to give me plus 3/2 to the power 17. And on the bottom, we'll have 1 plus 3/2, which is 5/2. So finally, if we divide by 5/2, we'll have to multiply by 2/5, and therefore multiply 4 times 2/5 is going to be 8/5, and then we'll multiply this by 1 plus 3/2 to the power 17. And if we want this value, we'll use calculator and compute approximation of that value. But this is the exact sum of that 17 terms of that geometric sequence.